So the situation, rectangular gate 3 meters high and 1.5 meters wide is hinged at the top. A force to keep the gate closed is applied at the bottom with an angle of 45 degrees with the vertical. So compute the magnitude of this force in kilonewton if question letter A, the water surface is level with the top of the gate. So let's remember our hydrostatic force formula, which is F is equals to gamma bar H times the area. So in solving this, we also need to look for our bar H, and that is just half of our 3 meters, the height. That is 1.5 meters. Also, our hinge is located here at the top. So we can now solve our hydrostatic force, that is 9.81 times our bar H, which is 1.5 times our area, 3 times 1.5. And let's just use our calculator here. That's 9.81 times our bar H, which is 1.5 times the area, that's 3 times 1.5, and that's equal to 66.218. 66.218 kilonewton. So now we already have our hydrostatic force, and it is here. Yeah, this is where our hydrostatic force located. We can solve it by um, doing or using the formula, which is 1/3 height, and that is 1/3 times 3, and that is equal to 1 from 1 meters from the bottom. So we can use this formula 1/3 each because our water, the shape of it is just triangular. So here it is 1/3 from the bottom and 2/3 from the hinge. So we can put it here, that is 2 meters. So since we already have our location, we can also put into x and y component our force since it is with an angle. So this is Py and Px since this is a horizontal and vertical component. Also, here, since it is 45 degrees already, here we can also say that this is 45 degree. And for our Px, we can say that P cosine 45 and our Py is P sine 45. We're just using the angle, the red angle, which is the 45 in color red. So also in we can now do our summation. That's our reference is at the hinge. That summation moment at hinge is equals to 0. So summation forces, the hydrostatic force and its moment arm times the force to keep our gate closed times its moment arm. Since here the distance or the location of our px is cannot be or difficult to look, we can use our principle of transmissibility and we can transfer it here at the bottom. That is px or p cos 45. Um, we can use it or we can move it along its line of action. So the distance from the hinge, that is 3 meters. So we can now do our summation moment. That is 66 times 0.218 times the moment arm, which is 2 meters, and equal to P cos 45 times our summation moment arm, which is 3 meters. And we can have our force to keep our gate closed. That is 66.218 times 2 equals to x cosine 45 times the moment arm of 3 meters and shift solve. That is 62.43. This is 62.43 kilonewton. And here, our answer is letter B.